YC Leon. Today I will introduce you the collision. Okay, look at the car accident picture. Why the small car was broken so much? I will show you. Okay, in my discussion, I guess that kinetic energy and momentum are conservation. And in one dimension, there are three situations. Two balls which are the same have a collision. Big ball collides the small ball, and the small ball collides the big ball. Okay, the two balls which are the same have the collision. What will happen? This is ball 1 and this is ball 2. The ball 1 have the initial velocity, and he move and collide the ball 2. And the velocity will exchange. So the ball 1 will stationary, and the ball 2 will move. And the velocity of ball 2 is equal the velocity of ball 1. Okay, the big ball collides the small ball. What will happen? Because the big ball is so big to the bigger than the small ball. So it moves and collides the small ball. It will move and go straight continually. And the small ball will move and its velocity is faster than the big ball. And the velocity of big ball doesn't change. Okay, the small ball collides the big ball. What will happen? Because the small ball is too small to the big ball, so it collides the big ball. It collides the wall, and it will remain. So the initial velocity of the small ball almost doesn't change, and the velocity of the big ball is almost 0. Okay, above of I said is in one dimension. In two dimension, what will happen? When two balls have a collision, no matter which is bigger and no matter which is smaller, they collide and they're moving Lucas, and their included angles were 90 degrees. It's very interesting. Okay, now I will show you the collision. Two balls which are the same have a collision in the horizontal orbital. Do you see that? The velocity exchange. Later, it's the small ball collides the big ball. You see, the small ball rebound. Okay, and the last one, the big ball collides the small ball. What will happen? You see that? The velocity of the big ball almost doesn't change, and the small ball move and gone.
I want to talk about Roman arc. We know that Roman arc has existed for such a long time, but why could they maintain stable now? There must have something to do with important physical principle. Actually, the principle of Roman arc is very simple. It is called equilibrium. When an arc bridge sustains the gravity of transportation and people, it could differentiate the gravity from vertical and horizontal side, their direction. The vertical force is counteracted by the normal stress given from Earth, and the horizontal force is balanced by a normal stress given from piers on both sides and the friction given from ground. When an arc reaches to equilibrium, the structure of it will be very stable. Now, this is model of Roman arc. You can make a similar model at home by yourself. The materials are just some cardboards. I want to show you a little experiment. This is a board. I want to put it on the model and see if it could sustain or not. Now, the system reached equilibrium. Because this model doesn't have extra piers on both sides, so we need to put some additional mass on the bottoms of it so that it could offer enough friction to balance the horizontal force. The last thing is about the keystone. We know that when we build a bridge, we started from its both sides. When we are going to finish the work, putting on the keystone is a very important step. If the keystone doesn't connect precisely, the bridge will collapse immediately. Now, look at the model. If I move the keystone, it will collapse. See? It's very interesting.
Hello everyone. Today I'm going to introduce AFM. AFM, Atomic Force Microscope. AFM is a kind of resolving power of atomic microscope. Can be operated in a vacuum, gas, and liquid environment application. Such microscope is use a special small pulp to detect pulp between the needle and the sample space. Atomic files. When pulp tip is determined by the beam, the 4M subcomponent. When the pulp tip in contact with the sample space, the tip and the sample space atomic force pulls the pulp up down. The figure is
Now I'm going to introduce the three kinds of AFM. 这句怪怪，重来好。
剪掉没关系。
Now I'm going to introduce the three kinds of AFM operation mode. The first kind of operation mode is contact mode. It is the first mode of operation has been developed. In this operation, the force between the probe and the sample is the repulsive force. The repulsive force between atoms is very sensitive to the distance. The force between the probe and the sample is small, but the contact area is much smaller. If the force is too strong, it might damage the surface of the sample, but larger force can gain better resolution. The second mode is non-contact mode. To solve the shortcomings of damaging the sample, there is non-contact mode AFM. It uses the long-range attraction between atoms, Van der Waals force, to operate. Van der Waals force on the chains in distance is very small, so we must use special technology to enhance the signal to get an image. It has the highest resolution in the AFM mode of operation. The third one is tapping mode. Tapping mode is between contact and non-contact. Probe vibrate in a high rate of frequency in the Z direction, but the amplitude is smaller than non-contact. Because of the probe contact with the sample, it has better resolution than the non-contact mode. Although the resolution is worse than contact mode, the damage of the sample was greatly reduced, and the frictional force interfered less.
FM is used attractive and explosive force between atomical effect, causing the pop up and down, and then change the signal generator with the computer mode to simulate the surface of the sample on the force. By this, usual to understand is more attractive and explosive force relationship.